Hi everyone, I'm Stephen Ott from Texas Instruments in Silicon Valley. As system designers, when you're looking for a power management solution for relatively low power rails, you'll often have a choice between a switching regulator or a low dropout linear regulator, also known as an LDO. Today we'll examine both solution types and weigh the pros and cons of each in a few common scenarios you might face. But in each comparison, the switching regulators we'll use will be from TI's family of easy-to-use simple switcher nano modules, which are synchronous switchers with integrated inductors in a tiny solution size. As many of you have learned over the years, LDOs are typically a simple, small, quiet, and sometimes inexpensive way to regulate an output voltage when it's powered from a higher voltage input. The key internal pieces to an LDO are a MOSFET or bipolar junction transistor acting as a pass element and a differential or error amplifier. LDOs need no inductor, but usually will have external input and output capacitors. The advantages of a low dropout regulator over switching regulators include low noise since there is no switching involved, generally smaller devices as larger inductors or transformers aren't needed, greater design simplicity, and usually a lower cost. Because an LDO's internal pass element essentially acts as a variable resistor, the primary disadvantage of LDOs is that they are much less efficient and they create higher operating board temperatures. Another possibility for this type of socket is an inductive switching regulator. In a common integrated synchronous switching regulator, the MOSFETs are internal to the IC, and an external inductor and capacitors are needed for energy storage and filtering. Now, the switching regulator's main advantage compared to the LDO is much greater efficiency. Because the MOSFETs dissipate little power when acting as switches, other advantages include easier heat dissipation and lower PCB temperatures due to that higher efficiency and more options in voltage conversion. Disadvantages of switching regulators include greater complexity in design and layout, the need for an inductor, managing switching noise, and they can be more expensive than LDOs. But in the case of the easy-to-use simple switcher nano module, the inductor is integrated, as are both the high side and low side FETs. This greatly simplifies design and layout and helps to reduce noise, all with a tiny compact solution size similar to that of an LDO. Now let me show you two example applications where you might choose between an LDO and a switching regulator. In these examples, the answer historically would always be an LDO, but with the nano module, that answer may now be different. Let's take a look. In our first example application, we have a system that's driven by a variable Vin from 3.3 volts to 5.5 volts. Delivering an output of 1.8 volts at half an amp, and the key design requirements in this case include power dissipation and solution size. So let's compare two alternate devices for this application, LDO and a simple switcher nano module. For the LDO, we'll use TI's LP38693, a low dropout CMOS linear regulator that provides tight output tolerance, extremely low dropout voltage, and excellent AC performance. For the switching regulator, we'll use a simple switcher nano module, the LMZ21700, a step-down DC-DC solution capable of driving up to 650 milliamps in space-constrained applications. Comparing the performance of each device in this application, both the LDO and the nano module meet the input and output requirements with the same solution size. But the LDO requires more than 50% additional PCB area than the simple switcher module to dissipate the heat, and its max temperature is much hotter than the simple switcher, even while occupying more PCB area. And comparing the results here, we can see that the better fit in this application would be the simple switcher nano module. In our second sample application, we have a system that's powered by a Vin of 3.3 volts, delivering an output of 1.8 volts at 1 amp, and the key consideration for this design is the need for a small solution size. In our comparison, the LDO will be TI's TPS7A37, a linear LDO regulator that uses an NMOS pass element in a voltage follower configuration. And we'll compare that to TI's simple switcher LMZ20501 nano module, a synchronous step-down DC-DC solution with an integrated inductor capable of driving up to 1 amp of load. When we compare the devices for this application, you can see that both solutions deliver the nominal application specifications, and they both have similar features, though the nano module includes a power good pin. The difference between the two is that the simple switcher solution size is nearly 25% smaller than the LDO. So the better fit in this application is again the simple switcher nano module. So this is just a sample comparison of the pros and cons of both the LDO linear regulator and the integrated simple switcher nano module. As you begin with your next power supply design, even for conversions where you have always used an LDO, keep in mind that there may be a better option out there. In many cases, we found that customers see more benefits in choosing the simple switcher nano modules for their designs, once they've considered all the parameters and advantages. Take a few minutes and learn more at simpleswitcher.com, where you can get a lot more information on the easy-to-use simple switcher families of modules and regulators, plus links to the WebBench online design tools and other design resources from TI. That will wrap things up for this video. Thanks for watching.